Have you ever looked up at the night sky and just felt a sense of wonder? A feeling that you are part of something vast, ancient, and full of secrets? The cosmos is a grand theater, and honestly, we are just beginning to pull back the curtain on its greatest performances. Every now and then it sends us a traveler, a messenger from a distant star system, reminding us that our solar neighborhood is not alone in the immense cosmic ocean. These visitors carry tales of their origins, of star systems wildly different from our own. Imagine a rock, or maybe something more, that has journeyed through the silent, cold darkness between stars for millions, perhaps even billions of years, only to cross our path for a fleeting moment. The discovery happened on a quiet night, not with a bang, but with a flicker of data on a computer screen. Astronomers, diligently mapping the sky with powerful telescopes, were conducting their routine surveys. They are the sentinels of our solar system, watching for anything that moves against the backdrop of distant, unblinking stars. Their goal is often to find asteroids, comets, our local neighbors. But on this particular occasion, the computer algorithm flagged something unusual, an object moving too fast. Its trajectory was all wrong. It wasn't orbiting our sun in a gentle, predictable ellipse like a planet or an asteroid. It was on a one-way trip, a cosmic slingshot that was merely grazing our system before heading back out into the void. This was the telltale sign of an interstellar guest, an object born not in our solar system, but in the crucible of another, far-off star. Scientists around the world turned their instruments toward this fleeting visitor, racing against time to gather as much information as possible before it disappeared forever. So what could make a cold, dead rock glow as it travels through the vacuum of space? This question became the central mystery. The most straightforward explanation for a glowing object in our solar system is cometary activity. Comets are essentially icy dirt balls. When they approach the sun, the heat vaporizes the ice, creating a magnificent glowing halo, a coma. However, when astronomers pointed their spectrographs at this new visitor, they found none of the typical chemical signatures of water vapor, nor did they detect other common cometary gases. The usual suspect was missing from the crime scene. This lack of a cometary tail was a major blow to the simplest explanation. If it wasn't ice turning into gas, then what was generating the light? The glow was faint but undeniable, a self-contained luminescence from the object itself. Scientists began to explore other possibilities. Could the glow be caused by chemical reactions on its surface? Perhaps exotic materials reacting to the sun's charged particles, the solar wind. That interaction could excite atoms on the surface, causing them to emit light, similar to how our auroras form, the northern lights and the southern lights. When faced with a true cosmic unknown, scientists must keep an open mind to all possibilities, from the mundane to the truly extraordinary. The hydrogen iceberg theory, for example, suggests a new class of cosmic object we've never seen before. The idea of stored energy from cosmic rays paints a picture of a universe that is far more interactive and dynamic than we might have imagined. These are plausible science-based hypotheses that can be tested with further observation and modeling. However, whenever we encounter something truly anomalous, something that defies easy explanation, the human imagination naturally wanders to more speculative realms. Could this glowing visitor be something other than a natural object? This is the territory of what some call speculative science, the question of alien technology. Could the faint glow be a byproduct of an interstellar probe? Perhaps it's the faint hum of an engine, the glow of an energy field, or simply waste heat from internal electronics that have been running for millennia. This is an extraordinary claim, and extraordinary claims require extraordinary evidence. We have none. The idea of an alien artifact, while captivating, is what we call the hypothesis of last resort. Before we can even begin to entertain such a notion, we must exhaust every single possible natural explanation. The universe is a vast and strange place, and it has proven time and again that it can produce phenomena far more bizarre than anything we could have predicted. Nature is often more imaginative than we are. So how do we study these fleeting messengers from other star systems? It's a race against the clock. From the moment an interstellar object is identified, alerts trigger wide-field surveys. Ground observatories scramble. Space telescopes jump in. Teams coordinate to capture every photon of light they can. First, we measure its trajectory. That tells us speed and direction, which confirms an interstellar origin. Powerful telescopes with spectrographs break the light into a spectrum. The spectrum reveals chemical composition. It also shows what it isn't made of. We track how brightness changes over time. Those subtle flickers tell us a lot. The pattern gives rotation rate and a rough shape. The future is exciting. The Vera C. Rubin Observatory will scan the sky every few nights. It will find dozens or hundreds of interstellar visitors a year. With a larger sample, we can look for patterns. Are glowing objects common or rare? Do they come from the same region of the galaxy? Look up at the star-dusted night sky. It's not static. It's a dynamic living space. In the darkness between stars, countless visitors wait to be discovered. Simple rocks, icy comets, glowing enigmas that challenge what we think we know. They are the galaxy's whispers. Our job is to learn how to listen. What other wonders drift through the void, waiting for a chance encounter with our tiny, curious world? The adventure is just beginning.